I'm covering 2-8 Part 1 today. It's solving absolute value functions, and we're going to start with looking at compound inequalities. And we're going to, actually today we're just going to start this looking at solving absolute value equations and inequalities. So what is a compound statement? It's made up of more than one equation or inequality. So let's look at disjunction. So there are two major classes of compound statements. Disjunction is a compound statement that uses the word or. So here's an example. X is greater than 2 or X is less than or equal to -3. So this is an or statement. This is the graph of an or disjunction. And this is the set builder. Notice they have a U here for an or. You can choose to use that, start using that. It's something you're going to see in later math classes. If you prefer just to use the or, that's fine. So X such that X is less than or equal to -3 or X is greater than 2. A disjunction is true if and only if at least one of its parts is true. And we'll look at this later, but something to remember. A conjunction is a compound statement that uses the word and. So here's a number line where X is greater than or equal to -3 and less than 2. So notice this part looks the same. The only difference is the word in the middle, which is an and. But the number line, of course, looks quite a bit different. Here's the set builder notation. We're actually missing. So it should be, well, no, that's actually, yes, there should be an upside down U there to represent the and. So it would be X such that X greater than or equal to -3 union, or actually intersection, X less than 2. Again, you can use the upside down U or you can use the word and. A conjunction is true if and only if all of its parts are true. Conjunctions can be written as a single statement as shown. So this is how we kind of have been writing them, with the X in the middle, the lower bound here, the upper bound here. And probably if we can get used to writing it that way, that would be the best. Okay, solve the compound inequality, then graph the solution set. So X minus 5 is less than -2, or -2x is less than or equal to -10. So we're going to solve each of these individually and then graph each of them kind of individually. So solve both inequalities for X. The first one we're going to add 5 to both sides. This one we're going to divide by -2. Remember, that switches the inequality, the direction of the inequality. So as you can see right here, whoops, it's been switched. So here we have X is less than 3 or X is greater than or equal to 5. So if we graph it, well, here's the solution set. The set of X such that X is less than 3 or X is greater than 5. And then we just graph X being less than 3 is here, X greater than or equal to 5 is here. This is the interval notation. So -8 to, or -infinity to 3 union square brace 5 to infinity. You can specify the solution set in either form. All right, so you solve this inequality. I would like the solution set either in set builder or interval notation, and the number line as well. So this is the graphing part. All right, next example. Solve the compound inequality, then graph the solution set. So here we have an and. 1/2 C is greater than or equal to -2. And 2c plus 1 is less than 1. So just like before, we take each of these inequalities and solve them separately. Here we're going to multiply both sides by 2, and here we're going to subtract 1. And then when you divide, you get 0. Divide both sides by 2. 0 divided by 2 is 0. Here we get c is greater than -4. And remember, this is an and. C is greater than or equal to -4 and less than 0. So solution in interval notation looks like this, or you can say x such that x is greater than or equal to -4. Actually, it should be c, but it doesn't matter. And x less than 0. If you graph it, it's going to be this space here between -4 and 0. All right, here's one for you to try. See if you can solve and graph this one. All right, so how does this all relate to absolute value functions? Well, absolute value functions are actually like compound statements. So recall the absolute value function of a number x written like the vertical bar x vertical bar is the distance from x to 0 on the number line. So the absolute value of 5 is 5. It's 5 units, whether absolute value of -5 is 5, because -5 is 5 units from 0. And here they have it, the absolute value of x equals x if x is greater than 0, -x if x is less than 0. Which I think is a little bit confusing to think about, because we think that's kind of backwards as to how we actually think about it. So absolute value equations and inequalities can be represented by compound statements. Consider the equation absolute value of x equals 3. And we are kind of going backwards. What values of x will make that equation true? Well, the values of x that make it true are going to be points 3 units from 0. So that's going to be when x is equal to -3 or x is equal to 3. So, and the graph of the number line is just going to be 2 points at 3 and -3. So this is a disjunction because it's an or. If we look at absolute value of x is less than 3, so what does it mean? It means we want the values of x that are less than 3 units away from 0. So if you think about it, it's going to be a conjunction. It's going to be that the points from -3 to 3. That's the solution of absolute value of x is less than 3. Those are all the points that are less than 3 units away from 0. So if we graphed it, it would look like this, going from -3 to +3. So absolute value function with a less than is going to be a conjunction. And this is something we're going to need to remember for the next time. And then on the other side, if we have the absolute value of x is greater than 3, these are points that are more than 3 units from 0. So this is going to actually be a disjunction. And this is the confusing part of absolute value. But if you think about what it's actually asking you, it makes sense. This clearly absolute value of x greater than 3, points that are greater than 3 units from 0. So it's going to be x is less than -3 or x is greater than -3. Here's your number line. So last thing we want to that we're going to cover today, absolute value of x greater than is disjunction. Whoops. Which means it's an or. We're going to get into more complicated inequalities tomorrow, but that wraps up this lesson. This is the homework. Bring any questions to class.